Okay, so let's see for this particular data set, and then we'll look at another one in a minute. How do I determine this? So first, I already have the interquartile range in our example is 10. How do I determine the upper fence? So I have Q3, which is 38, plus 1.5 times 10, and the lower fence, which is Q1, which is 28, minus 1.5 times 10. So this one is 38 plus 15, which is 53. And this one is 28 minus 15, which is 13. So, I have my, maybe I shouldn't go back there. Let me write them again here. So the minimum is 20, the maximum is 40, and we had Q1, Q2, Q3. So Q1, Q2, Q3, again, these were 28, 32.5, and 38. Okay. So as you see, the upper fence is up here at 53, and there is no observation above 40. I don't have an observation above 40, and the upper fence is 53. So this is the upper fence. Where is the lower fence? The lower fence is right here at 13. I don't have a number lower than 20, lower than 13, definitely. So this is minimum, and this is maximum. So because of that reason, I will say this data set has no outliers. Any questions?
If one of the limits is in the minimum maximum, so say if the
if the minimum is like 10, I have an outlier.
Okay.
If the maximum number is not 40, but 54, then I have an outlier.
Okay.
We're going to look at an example right now. Thank you, Gabe. Yeah. So before we look at 3.5, I would like us to just mention one more thing here. And that's page 4. Something called deals with the what we report. So which measure to report? That's the question. And we have two possibilities. So first of all, we're going to look at 3 different things. So the shape of distribution, then measure or measures of center, and measures of dispersion. So basically we looked at, yes, you can say we looked at 3 distributions, uniform, symmetric, and skewed. Yeah, but we are basically looking right now at symmetric, L-shaped, in other words. That's one option. And the other one skewed. Okay. So if the distribution is symmetric, what do we report as the measure of center? What is the best measure of center if the distribution is symmetric? Give it a shot.
Mean.
Thank you very much. Who said that?
Emma.
Thank you. Very good indeed. Okay. What do we report the best measure? What will be the best central measure of center for the skewed distribution?
Wouldn't it be the median?
Thank you very much. Who was that?
It was Emily.
Thank you. Excellent. Which Emily? K or V? I have two Emilys.
That was K.
It was K. Thank you. Good. Okay. So now let's talk about the measures of dispersion. If it's a symmetric distribution, what do we report immediately and what we are comfortable with for the measure of dispersion?
Standard deviation.
Excellent. Who said that?
Emma.
Thank you. Very good. Well, I wanted to make sure now that we understand that for the skew distribution, we will be reporting the IQR, the interquartile range, for the measure of dispersion. So for the skew distribution, the IQR.
Is there a reason why we want to use IQR?
It's the best measure. It shows the middle 50%. It's the best measure for a skewed distribution. Okay, finally, so we can finish this chapter. Many of you are already in chapter 4. Thank you very much. You don't need me, I guess. That's heartbreaking when students don't need me. Kidding. So the 5-number summary and box plots. Okay. So let's enter this data, and then we'll look at problems in my lab math. So I'm going to share my screen. I already entered the data, so I can focus on you and not on my data entry, and I called it. So please save this. Don't do anything. Just go to Stat, Save. So click on Save. I'm sorry, here, and save everything, so you can go back and look at it or play with it, etc., and save everything. Okay. So here's the second data set and the last one for today. I called it bank rates. So here's what we need to enter. It has 2 columns. I did not copy the name of the institution. I'm gonna post this for you after class anyway. So just enter in institution, the first column, label it institution or INST, whatever you want, short. And then I'll dictate PB, RP, when you're ready, WF, and as I said, the specifications will be posted. FC, LA, INF, UB, FNAT, BL, and bar. And when you're ready with that, I'll dictate the rates. There are only 10 entries. So we can create a box plot and a 5-number summary. It's the order, the correct order is the 5-number summary and then the box plot. So 6.5, can I read the rates to you or not yet?
Yes.
6.5, 12, 14.4, 14.4, 14.3, 13, 13.3, 13.9, 9.9, and 14.5. I'm going to stop sharing for a second to clarify what this represents. Okay, the minimum, the Q1, Q2, Q3, and maximum. These are so-called the 5-number summary. Okay, so let's determine them. I'm going to share now. So go to Stats, Summary Stats, Columns. You have to choose the rate. And then I'm going to choose, where's my keyboard? I'm going to choose I don't want the mean, but I want the median. I want the median. I want the minimum. No, I don't need the range. Well, it just does what it wants to do. I want Q1, I want Q3. Yes, I want the interquartile range. It will consider the sum. I don't want all these. Okay, never mind. Okay, so I'll just take what I need. So what I need from all this is just those 5 number summary. So I have the minimum, 6.5. I have the maximum, 14.5. I have Q1, which is 12. I have Q3, which is 14.4. I have the median. Where is my median? 13.6. And Q3 again, 14.4. And they already calculated interquartile range for me, 2.4. Perfect. Okay. Good. Now we want to determine or build something called a box plot. And you can say why. It tells us a lot about the distribution, whether it's symmetric or skewed. It tells us. Yes, please.
Is there a reason why? So this IQR it's not part of the 5 number summary, is it?
It's not, but we have to determine it because we have to determine. Very good question. It depends on this, the IQR. We will be able to determine the upper fins and the lower fins. Without the IQR, I will not be able to determine these, and therefore I will not be able. Very good question, Gabe. Thank you. I will not be able to find or draw the box plot.
Thank you.
Thank you. Very good question. That's why I copied it. Okay, so then again, the minimum is 6.5. So I'm going to say this is 0. And I have to go to maximum 14.5. So 2, 4, 6, 8, 10, 12, 14, 16. Okay. The minimum is 6.5. 2, 4, 6.5. So somewhere here. Min. Maximum is 14.5, so this is 14, this is 15, so this is 14.5. So I'm going to write, so this is 6.5, and this is 14.5, and this is the maximum. And I signify those with a vertical bar. Okay, now Q1. Q1 is at 12. 6, 8, 10, 12. So this is Q1. Q2, 13.6. So this is 13, 13.6. And 14.4. So this is Q2 and 13.6. And right here. And the next one will be 14.4. And this is Q3. I connect with something called whisker. So this is my box plot. However, it's not as useful as what it's called a modified box plot. The modified box plot identifies the outliers if they exist. Maybe they don't. Maybe we don't have any outlier. But the modified box plot takes into account the outliers and presents them. Here I don't see anything. Okay, so how do I determine the outliers? As we know, I have to find the upper fence, which is Q3 plus 1.5 times the interquartile range. In our case, Q3 was 14.4. And then plus 1.5 times 2.4. I'll come back and determine that. And the lower fence is Q1 minus 1.5, the interquartile range. So Q1 was 12 minus 1.5 times 2.4. Grab my calculator, it's right here, ready? 14.4 plus 1.5 times 2.4. And then 12 minus 1.5 times 2.4. So this is 18, this is 8.4. So now the modified box plot will still have 0 to 16. The minimum is 6.5. Here the lower fence is 8.4. So obviously the 6.5 is an outlier. So 6.5 outlier. Now the upper fence is 18, but the minimum is 14, the maximum is 14.5. So this is the only outlier. So this at minimum at 6.5. What was the my minimum? Yes, 6.5. So why did I do it? Oh yeah, because it's 6.5. Yeah, that was 6. Perfect. Okay, so this one becomes a star. And now the next observation becomes the minimum. So we have to go and look at the data set. Where is my data set? So 6.5 is the smallest. The next one in line is 9.9. So now the minimum, so 6, 8, 10. So 9.9, so this will be right here. So this is 6.5, and here at 9.9, it becomes the minimum. And then I copy the rest. Nothing else changes. I just don't want to waste your time and put the numbers in, but because you got the picture. And that is this. This is the modified box plot, specifying the outlier. So the next in line becomes the minimum, which was this time 9.9, and everything else is Q1, Q2, Q3. These still contain this box. This is the box. Still contains the middle 50% of the data set. So this is a box plot, but this is the so-called modified box plot that specifies the outliers. Okay, so I'm going to share my screen and show you the box plot